gentlemen, Mr. Chairman, thank you for the presentation, for introducing me. The title of my presentation is Use of Ancient Latin American Crops in Bread, Effect of Mineral Availability and Glycemic Index. This work was developed in the Institute of Agrochemistry and Food Technology. First of all, I want to thank the organizer for giving me the opportunity to present on this work in this conference. Products with whole grains generally have a lower glycemic index than their fiber-free counterpart, maintaining better control of blood sugar levels. However, whole grains contain significant amount of phytate as well known inhibitor of mineral, proteins, and trace element bioavailability. We use in this work quinoa, amaranth, and chia. Quinoa is from the region of Peru and Bolivia, the Andean region of South America, and it was used 300 years ago. And the main characteristic of its pseudo-cereals is the high biological value of its proteins. Amaranth was used by Aztecs in the region of course, of Mexico, between 600 and 800,000 years ago. And the main characteristic of this pseudo-cereal is the high amount of minerals, 3 or 5 times more than cereals. But we have to be careful in this point, because if the minerals are high, in a high concentration, also the phytates are in the high concentration. But also they have also different nutritional qualities, and we will see later. Chia is an oil seed. It was used by Mayas and Aztecs in the region of Mexico and Guatemala 3,500 years ago. He is rich in oil, of course, because it's an oil seed, but it's rich in omega-3 fatty acid. Because its exceptional nutritional qualities, its adaptability to different agroeconomical soils, and its potential contribution to the fight against hunger and malnutrition, the last year has been declared the International Year of Quinoa by the Food and Agriculture Organization. Amaranth is also a pseudo-cereal. Quinoa and amaranth, they have a high concentration of starch, because that's why they are pseudo-cereal. The composition is similar to cereals. So they have a high amount of data fiber, vitamins, protein also of high biological value, and minerals such as calcium, magnesium, phosphorus, iron, potassium, zinc, copper, and manganese. Chia has between 25 and 38% of oil, and between 50 and 67%, contained, between 25 and 38% of oil, and this is a really high amount of omega-3 and omega-6 fatty acid in the proper proportion. It's one of the main sources of omega-3 and 6 in the world. It has also high amount of antioxidants, of course, vitamins and minerals, with proteins with high biological value, and a high amount of fiber too. Chia doesn't have starch. It has a really high amount of fiber, between 30 and 55%, and this fiber is rich in mucilage, which absorb a large amount of water to influence which could influence the intestinal functional. After the hydration of seed, the mucilage form a gel around the seed, and after the freeze drying, it looks like this. This is in this picture. We can see the detail of the network of this mucilage that could be involved in functional activities in our gut, but also this mucilage has really very good characteristics for from the point of view of the technological value. Many countries have long consumed chia in multiple products, but here in the European Union, it was available since 2009, after the European Food Safety Authority permit the market of this seed. In the same year, the official journal of the European Union said that chia seed and grounded chia seed may be placed on the market in the community as a novel food ingredient to be used only in bread products with maximum content at 5%. Later, in 2013, the official journal of the European Union said that chia seed may be placed on the market in the Union as a novel food ingredient in baked products, breakfast cereals, and mixes of fruit, nuts, and seed up to 10% of level, only in these products. So what was our objective? In this study, we evaluated the effect of replacing wheat flour by amaranth, quinoa, chia, three ancient Latin American crops, on nutritional and functional bread features. Glycemic index and iron availability were studied using in vitro and in vivo methodologies, and wheat and whole wheat bread was used as control. In the picture, we can see the 5 formulations that are included in this study. As I've told you before, the first one and the second one are from wheat, so they are our controls. We use formulation with 25% of amaranth flour, 25% of quinoa flour, and only 5% of chia flour, according to the first recommendation of the European Food Safety Authority. We use this level of pseudo-cereal flours because it was the highest overall acceptability by consumer. We made many formulations, and with 25% of pseudo-cereals in the formulation was the highest overall acceptability by consumers. In this slide, we can see the picture of the different breads. They are different colors, but the whole wheat bread is really dark compared with the bread with the amaranth of quinoa. So that was better for consumer. The color, the volume of the bread also was not affected so much, because it's important to remark that the pseudo cereal don't have gluten. So the technological quality could be decreased when you replace wheat flour by flour without gluten, of course. But the best technological quality was for the bread with chia. With only 5% of level of chia, we saw better volume, crumb texture, and also acceptability by consumer, higher than the control breads. So, in the experimental animals, in our experimental models, we use experimental animals that were female Western rats. The adult females were decimated and fed ad libitum with an iron-deficient diet. At day 21, animals were randomly distributed in different groups of treatment. The animals were, for hematological parameters, the animals were fed intragastrically with the different bread formula in a single dose per day during 10 days. And for glycemic index, the animals were fasted for 6 hours and serum glucose concentration were determined by using an automatic glucometer. This experimental design was made in collaboration with the Dr. Moises Laparra, who is now researching in Germany. The whole blood samples were preserved in IDETA treatment tubes to prevent coagulation, and the hemoglobin concentration were measured photometrically using cyanomethaglobin standard solution according to the manufacturer instructions. The hematological parameter measured was the number of erythrocytes, which calculated by using Newer improved cells counting chamber, and hematocrit was estimated by centrifugation of whole blood in microcapillary tubes. We also measured the mean corpuscular volume and also the mean corpuscular hemoglobin. In figure 1, we can see the effects of different bread formulations on blood glucose levels in rats. We saw at the beginning a first step for glucose uptake, and also we saw that quinoa sample present a significant second step of glucose intake. We don't know what happened in this behavior. We are trying to understand why the quinoa has this behavior. At the moment we have, although they are preliminary results, but we cannot know, we don't know exactly what is happening. We are trying to understand what happened. In the figure 2, we can see the glycemic index, the bread formulation present advantages concern the glycemic index in relation to the white bread, especially in the whole wheat bread, in bread with chia, and in bread with amaranth. The molar ratio between phytate and iron can predict the mineral availability in human. So when this ratio is higher than 1, the prediction is that the bioavailability would be inhibited. So, but what happened with the hematological parameter? In this table we can see they in iron deficient diet, in animals fed with iron, and in animals fed with iron and together with the bread. We saw that the concentration of hemoglobin was really significantly higher in bread with amaranth and chia, and the mean corpuscular volume was higher in the three formulation of amaranth, chia, and quinoa, but only the mean corpuscular hemoglobin was higher in the bread with chia. So our conclusions were the replacement of wheat flour by Indian grains significantly increased the content of protein of the high biological value, lipids with unsaturated fatty acids, especially omega-3 in the case of chia and also in pseudo-cereals, dietary fiber and minerals in the final product compared to control sample. Amaranth and quinoa flours made wheat flour replacing impossible, increasing nutritional value of bread with slight depreciation of its quality, whereas chia showed higher technological and sensorial quality than wheat bread. Glycemic index was lower in bread with chia, amaranth, and whole wheat bread, where the formulation with quinoa did not modify this parameter. Bread formulated with whole grains had higher levels of mineral relative to controls. Their viability depends on the formulation and bread-making process, basically because of the presence of phytates, as predicted by inhibitory threshold values for mineral absorption. Animal fed with whole wheat, chia, and amaranth bread showed significantly higher hemoglobin concentration than those fed with controlled bread. Only animal fed with samples with chia had values of mean corpuscular hemoglobin significantly higher than controls. That's all. Thank you for your attention.
Have you done any correlation with the physicochemical characteristic of the product?
Of correlation with?
With chemical composition of the product to see which factor really correlate with the GI?
No, not at the moment, but we can take in account this suggestion.
What the main dietary fiber in shea? What the main fiber? The gel-forming properties of chia seeds.
Of chia seed?
Yeah, what the dietary fiber?
The fiber is between 30 and, in general, is between 30 and 50% of fiber. So, but in the 5% of level in bread is really very low concentration. It's only increased maybe comparing to the white bread, 1%, the increasement, I mean. 1%, only 1%, yeah, because it's really very low concentration.
Do you know what type of fiber components?
The mucilage. Mucilage. Yeah, mucilage. Is the main component in this fiber.
Thank you.